Hello students, welcome back to my channel Infinity Minds where maths is made easy. Today we shall be doing chapter number 4 of Ganita Prakash-I from class 8 Quadrilaterals, page number 102. Figure it out. Question number 1. Find the remaining angles in the following quadrilaterals. So there are 4 parts to the question. So the first part is, there is the name of the quadrilateral is pair. Quadrilateral pair, P-E-A-R. So as you can see, opposite sides are parallel. They are always marked with an arrow. Single arrow represents side PE to be parallel to AR, and the double arrow with the double arrow corresponds to the fact that PR is parallel to EA. So opposite sides have been marked parallel, and one of the angles, angle P, has been given to be 40 degrees. You are expected to get the values of all the other three. Okay. So now, as we know, that in a parallelogram, adjacent angles are supplementary. As such, angle P plus R would make a 180 degrees. Also, logically, you have two set of parallel lines. The adjacent one, this one would act, PR shall act as a transversal. So, interior angles on the same side of the transversal are supplementary, using that knowledge from class 7, which is straight away used as a property in class 8, that adjacent angles of a parallelogram are supplementary. We shall get this to be 140 degrees naturally. All this has been explained in my write-up. And once we have a set of two adjacent angles, the opposite ones are always equal. In a parallelogram, the opposite angles are equal. This is an important property for a parallelogram, that opposite angles of a parallelogram are equal. Now see, all these you must, in case you don't remember, you must visit the very first video that I have put up on quadrilaterals, in which all the various types of properties of various types of quadrilaterals have been included. Okay, so we'll just get this. This is the transversal. Interior angles on the same side of the transversal are supplementary, getting this to be 140 degrees, and then opposite angles of a parallelogram are equal. Okay. From that, you should be able to solve this. Moving to the next. Very similar on the same lines. If so, the shape has changed, nothing else. It remains to be the same. Parallelogram PQRS. Side PQ parallel to RS and RQ parallel to SP. Angle P given to be 110. Yes, someone can say straight away, I can get this to be 110. Yes. By using the property that angle R equals to P equals to 110, opposite angles of a parallelogram are equal. Of course, children, there is no harm in that. Whatever strikes you, there is no set way as to how you are required to proceed. Whichever angle you are able to solve first, you can do that. Now, these two are parallel. This is an adjacent angle. P is adjacent to angle S. So, P plus S, 180 degrees. You can get this to be 70 degrees. Someone may think that P plus Q is also adjacent. Yes, that property can also be utilized. There is no compulsion that I have to get an adjacent and then both opposites are equal. No need to learn up. It's about your concepts, your understanding. These two, if someone is able to think of an alternate answer, it's absolutely okay. Assuming it is falling under the correct set of properties. So if this is 70, someone may say P plus Q adjacent. Someone may be able to think Q plus R being adjacent. That with the help of R, I can get the value of Q. Yes. With the help of P, you can get the value of Q. With S, you can get opposite angles. So each one of them may lead you to the value of Q. No problems. You make sure you give the correct set of reasoning in the brackets. Okay. So let's just take a reading of the answer. Since the opposite sides of a parallelogram, this is a parallelogram. PQ is a transversal. These two are set of parallel lines, because somewhere they are also given they are quadrilaterals. So with the set of parallel lines, you have to talk about them being a parallelogram. Okay. So interior angles, angle P, yes, they have used 3 alphabets. Since the angle is not getting divided into further subparts, it is absolutely okay even if you just denote it by single P. If the angle gets divided into multiple parts, then it is essential for you to use 3 alphabet naming. Okay, so coming to this, angle P plus angle Q, according to, so the way they have, it is solved, angle P plus Q is 180 degrees. This comes out to be 70 degrees. From there, You are moving over, so we are getting the value of Q. We know that opposite angles are equal. Once you have this would be 70, this would again be 110. Okay, that's the answer shared, and rest I have also explained it verbally. Coming to part number 3. So here is a quadrilateral UVXW. See, UVXW is given, UVWX is given to you. Can I say it is a parallelogram? As such, yes, the arrows aren't made, even supposedly they are made. So it will not be wrong to call it a parallelogram, fine. But what is more essential is the presence of this particular line. What does this line talks about? What does this line talks about? It talks about the equality of each of the sides. Even though if you call it a parallelogram, it won't be wrong. Okay, fine. But with the equality of sides, it further falls into the name of rhombus. Rhombus is nothing else but after all a type of a parallelogram only. So that's not wrong to call it a parallelogram. But a more specific name would be to call it a rhombus. Okay, of course, if it is possible, you need to call it by that name. Maybe some property helps out. Okay, so it will be a rhombus of which you are given one particular angle. So rest of the angles you are of course you are to find. So there is a diagonal xv that has been used, which is okay. I'll come to that property later. So it is the diagonal. One of the diagonals xv is joined. This particular portion has been named. Value has been given as 30 degrees. So let us name it angle 1. Let us say that we are given angle 1 equals to 30 degrees. Now, so the diagonal is able to divide rhombus into two triangles. As such, if you notice this particular triangle, say XUV, if we talk of this particular triangle, it happens to be an isosceles triangle with side UX equals to UV. In an isosceles triangles, angle 1 and angle 3 shall play the role of base angles. Okay. If you notice this particular triangle, you have these two sides to be equal. So angles opposite equal sides are equal, which are also referred to as base angles at times, and you would obviously have them to be equal. So two of the angles of this particular triangle will get solved. This would also come out to be 30 degrees. Now in this triangle, if two angles are done, so obviously the third angle can be found using angle sum property. Right? See, in a rhombus, they have solved it with the answer that I have shared is another property. That is one of the ways. Supposedly, you solve it as base angles and then applying angle sum property. Another way is if we use this, one of the properties of diagonals of a rhombus, that in a rhombus, diagonals bisect the angles. Okay, what does it mean? That diagonal of a rhombus bisects its own angles which are at its end point. It bisects its own corner angles, opposite angles. Diagonal is nothing else but joining of opposite vertices. So the point from which it is arising, it bisects those particular angles. So you would be able to get angle 6 also to be equal to angle 1. Angle 6 would also come out to be 30. This has also come out to be 30. This will come out to be 30. This can be found with angle sum. It will be 120. Opposite angles of a rhombus would also be equal. Or someone may think of applying angle sum to the other triangle. All that is up to you. There are always multiple ways to reach answers. There is no one fixed way, children. As far as the method is correct, it is all acceptable. Okay, let's quickly take a reading of the answer slide that has been put up. So all sides are equal makes it a rhombus. Angle 1 given to be 30 degrees. In a rhombus, diagonal bisects the angle. So we shall get angle 6 also to be equal to 30 degrees. These two done. Now angle 1 equals to angle 3. Since the sides are equal, there is no harm. You could include the word base angles also next to this. Angles opposite equal sides. So you will get this also to be 30 degrees. Now the property of rhombus will be applied. This is also 30. Then angle sum property. In triangle UVX, applying angle sum property 30 30 and measure of angle 2, and then using the property opposite angles are equal. So this is 120, this is 120. See how many properties have we landed up using? First of all, base angles, then applying angle sum property, then using opposite angles are equal, and then the main usage of the property that is valid only for the case of rhombus. It wasn't possible had we taken it to be a parallelogram, that it bisects the corner angles. Okay, clear students? The way you had first two questions to be same, after doing first, the second was the repeat of the first part. Similarly, after doing the third part, the fourth is the repeat of this. In fact, I would like you all to first try and solve the fourth part on your own, only then have a look at the solution. Okay. So this is given to be 20, absolutely same, that this is a rhombus. If this is 20, I hope now it won't be a problem. This will also come out to be 20 as isosceles triangle. It will by rhombus diagonal shall bisect the corner angle. So these will also come out to be 20. Now using angle sum property, 20 20 makes it 40. So 140 degree left, and the opposite angles would also be 140 degrees. Okay. You could go through the answer slide. Here slightly different sort of an answer has been shared. Just slightly different. That also you can go through. If you feel that is comfortable, you can go ahead with it. Okay. Thank you everyone. Do keep watching the video. I shall be putting up the solution for the other ones also very soon. Okay. All the best.